I think at this point we can start to get into the creative process, okay? Where we're planning and then we're moving into the stage where you're going to build your submersible. But before we do that, I'd like you to collaborate with this packet here. So page 1 is just a check to see if your knowledge is there. So let's run through page 1 together. Let's have Gabby start us off by reading the question and the answer for number 1, Gabby.
Does your submersible need to sink or float? Circle 1.
Let's have a show of hands for sink. We need our submersible to sink. Okay, so the rest of you, the other 80%, think it needs to float. Okay, I agree with the float, but tell me why. Explain to me why.
If it's too heavy and it sinks, then we can't get it back.
Right. What are problems with the submersible that might, make it irretrievable? If the density is too high, it's stuck on the bottom. Why do we need it to float?
Because if the battery runs out, it could just float to the top.
That's right. If we lose power, the tether breaks, we want it to be able to recover it, okay? What I'd like you to do, since we're done with page number 1, is to flip to pages 2 and 3, okay? And start to decide what sensors you'd like to have on your submersible. You have to have lights and batteries. That's a de facto piece of equipment you need on your submersible. But just be careful. Keep an eye towards the density of the object, okay, its buoyancy, and if this submersible is going to be able to be recovered if you lose power.
Salt sensor.
Yeah. Okay. Let's focus on your design process. I notice your salt sensor's got this big X through it. Are you selecting that or not? Okay, why are you not selecting the salt sensor?
Because if you continue adding things that are too heavy, your ROV is not going to be able to go down and then pick up the equipment or thing that you need, which is already heavy.
This group's working really well. What I'd like you to do at this point is to go on to the next page, dial in your ideas, and then we get into the planning mode where you're going to start to illustrate what your submersible is going to look like.
These are the lights.
Here is the battery on top.
Yeah, but there's only one thing.
Yeah, I was going to put the sonar at the bottom.
Combine your two ideas. You get it? Like, if we combine yours, Danny, what were you thinking?
I know the main thing. I was going to put it right here.
Well, that was a good job today. I hope everybody had fun putting their packages together. Tomorrow's the real testing day. All right, estudiantes, welcome back. This is the last day of our culminating event of submersibles, testing them in the water. So today we're going to finish up our creating process, and we're going to go into our improvement process throughout the course of the day to see who comes up with the best design for this submersible, okay? So our guiding question is this today. How can we use our knowledge of floating and sinking in the engineering design process to design a submersible that meets the specific criteria? So what's the criteria our submersible has to meet? Give me a couple criteria. What are some of the things our submersible has to do? Okay, it has to be able to float, and it has to be able to float back up with the item we're retrieving. So it has to be buoyant enough to bring the item that we're retrieving back up to the surface. What's another criteria?
It has to have a great amount of density, because if it sinks, we can't be able to get it back.
That's right. It has to have the right amount of density, so if it sinks, we can't get it back. The other criteria that you might not be aware of is that your submersible has to have a light and it has to have a battery on it. Remember from our checklist? So when you add your component parts to it, make sure the lights and batteries are de facto part of your submersible. So your submersible today will be held together with an elastic with one magnet. Okay? So the procedure for today goes as follows. You're going to assemble your submersible, okay, based on whatever components you want to have. They're all in front of you on your desk. The first thing you'll do is once you assemble it with your group, you'll come up and test for the volume, okay? So I have 3 boxes up here. Which box has the largest volume? This one, or this one? Which one has the greatest volume? Gabby?
The third one.
The third one. After you test the volume to see where your submersible lies in the point range, you're going to go to any of the 3 tanks and see if it floats. This is not a point score system, but you know what happens if the submersible doesn't float. What do you need to do? You have to improve it. So you're going to have to go back to the drawing board, improve it, to get it to float. So your number one criteria is it has to float. So if, despite the volume being really small, it may be too dense, it may not float. So if it sinks, you're fine. You can move on to step number 3. Okay? Someone want to read step number 3 for me, please? Go ahead.
Take as many extra instruments on board as possible. You must have a battery and lights. This is your instrument score.
Okay, so your instruments were selected yesterday during the design and create process. All you need to do is include these two. You can have a myriad of other things, but just remember, the more instruments you have, the larger the volume is. Okay, but also, you know, the selection is going to increase or decrease your density based upon whether there's sand or beads or glass in there. That will be your instrument score. You're going to have your score sheet with you when you come to test it, so you can add and tally these up. The last step. What do we need to do once we determine what our instrument score is? We're going to take a submersible and test it. So why don't you read step number 4, please?
It needs to recover packages and float back to the surface. This is your package pickup score.
Okay, so your package pickup score is based upon if you can bring the package back up. Here's what your score sheet looks like. You'll get that in your packet. Okay? So we have your first box, 0, 3, or 6 points for volume. This is in a point category. This just prompts you to tell you whether to continue on if it floats or stop and go back to the design process if it sinks. Next criteria will be, what was your instrument score? That's another tally based on your worksheet that you have. And the final station is to test it out. So in the end, the total number of points wins. Okay, we want to have the highest score possible.
So, we need to have the battery. Yeah, the battery and the lights. Those are the most important things.
The video camera goes this side. And
We're not gonna use the sound recorder, right?
yeah, we are.
We are.
And you can
That one, okay, good. Okay.
another, what is it?
Video camera.
Go ahead, try it out. Let's try it in
There's submersible float or sink water. It floated.
What is your instrument score?
Our instrument score over here.
Battery 1, 2,
8.
8? Wait,
Yeah.
it's 8. It's 8. And then do you want me to double it?
Yes.
Okay, so what are we gonna change?
What can we do?
Make it less heavy. So what is the heaviest thing that
The battery.
like it's but it was on its side though. No, but the thing that we had to add because it's have to be there. The video camera was pretty.
Yeah, the video.
Yeah, the video camera was pretty dense. Yeah, but we have to get one. What about the camera?
Now, one thing I neglected to tell you throughout this design process, it's really important to name your submersible. So let's get a name for them, okay? Oh my God, this group did 15 points. What was your volume score? This group just got the maximum points. They had the smallest volume and they picked up the 15-point vial.
Oh wait, that's yours. Robert is so strong. Okay, so you have to add up all our points. So what did we switch out for this? What did we switch out for this? The manipulator.
So that concludes our study on submersibles. Unfortunately, we're going to have to move on to another topic. But now you have enough knowledge in the bank to talk about mass, density, volume, those keywords like buoyancy. We even talked about topography, the sonar. So the whole lot of information was garnered in 1 week. And you tell me if we've hit these points. Did you use your knowledge of density and sinking and floating to inform your submersible designs? Yeah. Okay, you informed your submersible designs by making improvements all the time. Did you evaluate your design using established criteria and use your evaluations to improve your design? That happened. I saw that happen, so good on you. And then did you identify and discuss the trade-offs associated with your submersibles? Did you collaborate and discuss buoyancy and density and make sure that your submersible is not only small enough but buoyant enough to lift the maximum amount? Yeah, I'm really impressed with the work you guys did today. I'm getting you a round of applause. I think the engineering design process works well when you do it in a group. And once you dial in your design, it's not final. You can go back and you can improve on it. And that's what I like about the last step in the process is that, you know, after you've created the thing, you test it out, and if it doesn't work the way you hoped it would, you can go back and redesign it and refabricate it and refashion it until you have it to where you want it. So that's what we stress on with the kids, and now when they see the engineering design process, they know that it's not final, they know it's not finite, and they know they're not on an island when they're making these things. It's typically a collaborative effort.